So we selected for our project chapter 10.2, and what that focuses on is risk. So all sorts of different stuff. The likelihood that you're going to get stung by a bee, likelihood you're going to get in a plane crash, all that fun kind of stuff. But what we decided to do was our project on these sets of problems in the book on AIDS. For those of you who don't know, AIDS is an infection that affects the immune system, and it is something that medical professions have done a better job of finding treatment for, but is still certainly a very dangerous thing for some people. So what we focus on specifically is the likelihood that the tests that people receive to get a diagnosis of whether or not they're infected are accurate. According to a couple doctors, they conducted a study that said roughly 0.003% of every 100,000 tests are a mixed diagnosis. So although it is very rare, it does happen to people where they get this news that they have this infection when in reality they actually don't, and it was just a missed test. So that's something that you can certainly relate to in everyday life, and that's why we chose this, because we wanted to prove that just because something's in a book and we learn it in school doesn't necessarily mean it's going to stay in the classroom and it's not going to carry over to everyday life. So we decided to perform a couple problems for you guys on the whiteboard to kind of show how it relates to everyday life. So for the first problem, is there are two tests. There's test A that has a 95% chance of being accurate, and then test B that has a 99% accuracy. So this is pretty straightforward. The problem simply just wants to ask, what are the odds that if a person receives positive results for both these tests? Positive results means that they in fact have the infection. They want to know what are the odds that this person, if they get a positive result, what are the odds that they in fact have this disease, because there is obviously a small percentage of a chance there that it was a misdiagnosis and they don't actually have the disease. So what we're going to do is we're going to set it up. So test A, like I said, test A has a 95% chance of being accurate, whereas test B has a 99% chance of being accurate. So what we're going to do is we're going to convert these two percentages to decimals. So we have the 95% to the 0.95 of test A, and then we have 0.99 for the 99%, and then we're going to multiply those two together. And when you multiply those two together, you get 0.9405, which converts back to a percentage of 94.05%. So that means that if a person gets positive results for both these tests, that means that there is a 94.05% chance that they in fact have this infection. So that was problem number 21, and I'm going to hand it over to Nurk, and he's going to take you through problem number 22.
So again, we have test A, which is 95%, and test B, that is 99%. In this problem, we are describing if one test came back negative or one test came back positive. So the question that we have to solve is, given the test described in the previous mindscape, assume now that the test A came back positive, test B came back negative. What is the probability that this person is actually infected? So the difference between this problem and the prior problem is that this time it is the likelihood that test B is actually wrong. So the first step, what we're going to do is subtract 1 minus 0.99 or equals 0.1 or 1%. Then after, we're going to convert the 0.95 times 0.01, which equals 0.0095, which equals 95%. And or 0.95, and there was a 0.95% chance that this person is actually infected.